Dear students, in this presentation, we will be discussing another topic on module first module topic, that is array operations. Here we will be discussing three operations like traversing, inserting, and deletion operation. Linear arrays. How do you define linear arrays? It is a collection of elements, but the nature of elements are of same type. Another restriction is that we know the number of elements in the array. So it is a set of finite number of homogeneous data elements such that the elements of the array are referenced by non-negative value. So that reference number is called index. Index cannot be negative number. Index can be 0 or any other number after 0. It cannot be negative. It cannot be floating point also. So there is no meaning for, say, if array is of integer type, array data type is of integer, array name is A, there is no meaning for the statement. That is A of 1.2. This has got no meaning. This is wrong. Floating point number is not used or cannot be used as index. So that is the restriction. The second point, the elements of the array are stored in successive memory location. For example, a integer data requires 4 bytes. That means it takes first 4 bytes in that allocated memory location 1, 2, 3, 4. Suppose that array started from the address 1000. So these 4 locations are allocated to the first element 1000, 1001, 1002, 1003. Next, that is from 1004, the second element starts. That is the meaning. 1004, 1005, 1006 and 1007. The elements of the array are stored in successive memory location, one after the other. 1000, 1004, 1008, like that. The number of elements, the total number of elements is called size of the array or length of the array. For example, if this is my array having some 5 elements 1, 2, 3, 4, 5. The size of this array is 5. Length of the array is 5. Actual number of bytes reserved for this array depends on the data type. If it is character and that character takes 1 byte, 1 into 5. If it is integer, a integer takes 4 bytes, 4 into 5, 20 bytes. In that way, the memory allocated is calculated. Based on that, we'll be calculating now the length or the upper bound. What is that upper bound? What is that lower bound? Like that. Suppose this is an array having 5 elements 1, 2, 3, 4 and 5. The total number of elements in this array, that is size of this array, is 5. So we can start that index from 0 or 1 or any other number. We call that particular index as lower bound. For this array, we will take LB as the lower bound. Suppose LB value is 0. What is the final value? That is, second element is 1, third element is 2, fourth element is 3, the last element is 4. How can you set a relation between LB, UB and size? So how can you express that value? So length can be computed as UB minus LB plus 1. We'll see that. LB value is 0 and UB value is 4. UB minus 0, UB minus LB. UB is 4 minus 0. 4 minus 0 is 4 plus 1, that is 5. If LB value is 0, this relation holds good. UB minus LB plus 1. Now we'll take other case, that is when array index starts from other than 0. Same example, 5 elements in this array. Now we'll take 1 as LB value. 1 as LB value. 1, 2, 3, 4, 5. Now we'll see whether it holds good or not. In this case, LB is 1 and UB is 5. UB is 5. So how do you compute length? Length or size equal to UB, that is 5, LB 1, 5 minus 1 is 4 plus 1, that is again 5. So that length LB, lower bound is not a matter. You can start from any number. Length can be computed as UB minus LB plus 1. Okay. Here we are not skipping the index value. Index value is continuous. Once you start from some number, that value is continuous. So how these elements are referred? Mathematically, these elements are referred as A1, A2, A3 like that till n. If there are 10 elements, these elements are referred as A1, A2, A3, A4, A5, A6, A7 and A8. That is the mathematical way of representation. In programming language, C or any other language, we use this kind of syntax to represent an array element. A is array name, 1 is the index. That 1 is given inside the bracket. If LB starts from 1 and UB is the final value, that is size. So all the elements are A1, A2, 3 like that till n. If LB value is 0, instead of starting from 1, we will be starting say 0. In that case, array elements are referred in this way: A of 0, A of 1, A of 2, like that till A of n minus 1, because we started from 0. All these are the elements of array. So these are the different way in which array elements are referred. In C, we use this particular syntax: A of 0 for the first element, A of 1 for the second element. What are the different major operations we can perform on array? The first is traversing. Here we visit each and every element of the array exactly once. Suppose 10 elements are given. Suppose 10 elements are there in the array. We are accessing all the elements. Say for printing purpose, it is a traversing. Exactly once we are visiting all the elements, starting from the first index till the last index. Processing can be anything: reading all the elements, processing; printing all the elements, processing; summing up all the elements, processing; traversing. These are all different types of processing. So here we visit each and every element exactly once. That operation is traversing. The second operation is to the existing array having some n elements. We are going to insert one new element to the array. The restriction is that new element data type must match with the existing array data type. Condition 2. The array size should not cross that max. Once you add that, no, it should not cross the maximum space allocated. If you maintain an array to hold 10 elements and we have got only 9 elements, we can perform insertion operation because there is one place for that new element. Suppose you have maintained an array, you have allocated array to hold 10 elements. Already 10 elements are there in the array, then you cannot perform insertion operation. You can insert anywhere, there is no restriction. You can insert the element in the beginning place, first place, or in the last place, or in the middle. To any place you can perform insertion. Removing one element, removing an existing element from the array is deletion. A condition for that, at least some element should be there. We can't perform deletion from the empty array. Nothing is there in the array, we cannot perform deletion. Next operation is finding out one particular element in the array, whether it is there in that array or not. If there, we are going to retrieve its position. We are going to perform some operation on that retrieved element. In that case, after the operation, that may produce one of the possibility. Either element there in the array or that might not be there in the array. Next operation, arranging all the elements. It can be in the ascending order, it can be in the alphabetical order, it can be in the descending order, anything. This is sorting. Next, joining more than one list. Having sub list 1 and 2 like that, I can combine into one master list. That is merging. So we are going to deal few of these operations, few for exercise. In this presentation, we will be discussing traversing, insertion operation, deletion operation. Rest of the operation in the next presentation. How array is represented? Before performing the operation, first you have to think how that array is represented. For example, these are my array elements 10, 23, 45, 65, 21, 22 are my array elements. As you can see, there are 6 elements, 6 data items, 6 items. Size of this array or the length of this array is 6. I can use any one of the representation. I can represent that vertically or horizontally. It's left to the user. If I use horizontal representation, I can start from index 0 or 1. Even in vertical also, I can start from index 0 or 1. All these are possible. We'll take one or two example. Suppose this is a representation used, horizontal representation. There are 6 elements here as you can see. We'll put all these elements in successive memory locations. We'll not think much about the address, physical address. We'll be representing all these theoretically. With the graphical notation 10, 23, 45, 65, 21 and 22 are the elements. And index are 0 for the first element. When we put 0 as the first index, we call that as LB, lower bound. 0, 1, 2, 3, 4, 5. The upper bound is 5. Also you can start from 1. If you are starting from 1, the index are 1, 2, 3, 4, 5, 6. If you apply that previous formula, you will get size. UB minus LB plus 1 is size of the array. Here size is 6. Also we can go with vertical representation. This is the way to compute size of the array. Upper bound minus lower bound plus 1. Now we'll see how that is actually represented in the memory and how to compute physical address of that particular element. Let LOC is the location of array A of position k. A of k means kth element in the array A. So LOC is the location. That can be computed as you have to add base address of that array plus W, word memory required for each of the element, word size. As you know that for byte it is 1, for integer it is 4, like that, into k minus LB. K is the position of interest. Which position you want to compute the physical address, minus from where you are starting the array, that is lower bound, lower index. We'll take one example. If this is an array starting address is 1000. So this 1000 becomes base address. This is the base address. This is the base address. And index we started from 0. This is LB. This is base address BA. These are the elements. 10, 20, 30, 40, 50, 60 are elements. Now I want to compute physical address of this position. Position 3. How do you compute? That can be computed as base address 1000 plus word size of each of the data 4, k value 3, lower bound 0. So altogether 1000 plus 4 into 3, 1012. 1012. This is the way to compute. This is the way to compute physical address of each of the element. But to compute that you should know base address. Visiting each and every element exactly once in the array is called traversing. Let A be the array, linear array. We'll take for simplicity display operation, print operation, printing the content of the array as traversing. So here to display or for printing, we have to retrieve the element, we have to access the element. Then you have to send that element to the output device, display operation. We are repeating this operation for all the elements starting from lower bound till the upper bound. Exactly once we have to visit the element. The algorithm goes like this. In order to apply traverse operation, we must know the array. Array is the thing to be passed to the function. Array should be known. On that array we are going to perform the operation. What is the lower bound and what is the upper bound? If you know at least two formats required, one is LB or size, LB or UB, anything is required, any one of that combination is required. Step, you have to start from the lower bound. So we'll set local index k equal to LB. From there you are going to start. You have to repeat till you reach the upper bound. K is less than or equal to UB. You have to apply the process. In our case, it is print operation. Printing the content of linear array. Printing the content of linear array particular to that particular position. After performing the operation, after applying the operation, you have to advance the index k by 1. K equal to k plus 1. Increasing the counter. Once we reach that last k equal to UB, you have to stop, terminate the operation. Okay. If this is array and 10, 20, 30, 40, 50, 60 are the elements, lower bound, lower index is 0, upper bound, upper index is 5, size is 6. We are starting now the traversing operation. K value is UB, that is 0. Element in that place is 0. So we will be getting 10. Next, k must be incremented by 1. K is pointing to the next element. K is pointing to next element. Then in that place the element is 20. We are applying the process. After applying the process, 20 is displayed. Increment the value of k. K now becomes 2. K is less than or equal to UB. Yes, true. K value is 2. Element in that place is 30. Apply the process. Process is display operation. 30. Now k is incremented. K becomes 3. 3 is less than or equal to 5. True. Element in that 4. In that place is 4. 4 is processed, printed. Incrementing the value of k. K becomes 4. 3 is added by 1. 3 becomes 4. 4 is less than or equal to UB 5. Correct. Element in that place is 50. 50 is printed. Index incremented. 4 becomes 5. 5 is less than or equal to 5. Yes, true. In that place element is 60. Process is applied. 60 is displayed. 5 is incremented by 1. 6. When k value becomes 6, this becomes false. 6 is not less than or equal to 5. The program is stopped. That's what we obtain. We get the result. 10, 20, 30, 40, 50, 60 are all the elements of array. Now, we'll take one example of finding out sum of all the elements and finding out the average. This is simple. Just go through this. Size of this array is 10. Elements are 437 minus 1720 4 to 13. We'll assume LB lower bound as 0, upper bound as size minus 1. 10 minus 1, 9. Initially we assume sum equal to 0, average equal to 0.0. We'll be starting I value, local index I, starting from 0. Same as the previous algorithm. Till that is equal to UB, you have to repeat. Till that becomes UB, you have to repeat. I less than or equal to UB. Starting from LB, you have to repeat till UB. I less than or equal to UB. Go to that element place 4. Add that to the sum. Sum value was 0. 0 plus 4 is 4. Okay. So like that you repeat till the last element. After reaching to the last element, you will get sum divided by number of elements, that is 10. That is the average. Okay. So that is traced here. How each time elements are processed. This is our array. Array name is x. X of I. X of I. Okay, 1 or 2 I can trace. Initially, I value is LB. LB is 0. I is 0. Element in that place is 4. That is added to the sum. The updated value of sum is 0 plus 4. 4. In this for loop, we are incrementing the value of I becomes 1. One iteration is over. This is iteration number 1. Now we are entering to the second iteration. I value is 1. In that place, the element is 3. 3 is added to the sum value. 4 plus 3, 7. I is incremented 2. That is the completion of second iteration. Like that, this is repeated for all the elements. Finally, we'll get sum. That is 41. Final I value is 10. That is not required for us. Sum divided by size. Size is 10. 41 divided by 10 is 4. As we need that in the form of floating, we have to cast it. 4.1, that result is casted to floating point 4.1 because sum is integer, size is also integer. 41 by 10 is answer 4, but we want exact answer. For that we can convert it by casting. Finally, you're going to print the result. Next operation, same thing, write a C function, not the complete program, a function to create an array with n elements and display array contents. Okay, now we'll assume array size is 10. Initially, at the time of creation, we don't have any elements, so we'll assume n equal to 0. We are going to use these many variables, not for this, generally. Array A of 10 size. This is the situation, the status of the array after creation. I don't know the number of elements. I don't know the content of those places. So I left as it is. Exactly 10 places are reserved for 10 elements. 1, 2, 3, 4 like that till 10 elements are reserved. Each element occupies say 4 bytes or 1 byte, depends on the data type, but in this case it is integer, so each of these holds requires 4 bytes of memory. Okay, now we'll be adding elements to the array. I will be adding some 4 or 5 elements to the array. N value is 5. I have to repeat starting from 0, I less than n, I0, I1, I2, I3, I4. When I is 0, I is less than n, correct, value is right, 10 is put in this location, I is incremented, I becomes 1, 1 is less than 5, correct, 20 is right, 20 is put, 40 is right, 40 is put, 50 is entered from the through the keyboard, 50 is copied here, like that for the last element. This is the status of the array after creation. Similar kind of statement for printing purpose, display. Okay, now max will not change, max will not change, size of this array is 5, size of this array is 5, it is not 4, it is 5, it is 5. Lower bound is 0, upper bound is size minus 1, 5 minus 1, that is 4. UB is 4, LB is 0, size is 5, n value is 5. Next we are going to retrieve it, we are going to traverse it. Display operation, for I equal to 0, yes, you have to start from here, I equal to 0, I less than n, n value is 5, I value should not cross that. Read that data, a of 0, a of 1, a of 2, a of 3, a of 4, that's all. Read the data and print that. So first element is 10, second element is 20, third element is 40, fourth element is 50, last element is 60. When you perform traverse operation, size will not change, content of the element, content of that array will not change, content remains same, size remains same. We are not altering the data, in this case we are not altering the data. Okay, so this is about traversing. The next is insertion. It is a process of adding new element to the array. As I told earlier, element data type, array data type must match. Element can be added to any place. It can be in the beginning, it can be in the middle, can be at the end. It is easy to add the element in the last place because we don't need to shift. The last place itself is the place for the new element. One restriction here is that at least some place should be there for the new element. If already filled, then we cannot enter that new element to the array. That gives problem because we cannot perform that insertion. We say that it is overflow, array is overflow. To perform insertion operation, the element has to be shifted. By shifting to the right side, you have to advance that element. Previous element should go to the next place. Lower index element should go to the higher index place. This is to make a room for the new element. And we will see with the algorithm. Algorithm or that function requires at least these information. One is what is the array of interest. LA is the linear array. N number of elements right now. Number of elements that are there in the array. It is not the maximum size but size of the array, length of the array. N is the length of the array. K. Where you are going to insert. Where you are going to insert. Item. What you are going to insert. What you are going to insert. The data type of this item and LA should be same. The first step will assume that the array whose maximum size is 10. In this case, 5 elements are occupied. 5 elements are added to the array after the creation. The first element is 10, 20, 40, 50, 60. I will show you how to insert. Inserting element 30 at position 3, that is index 2. Position 3, index 2. Here that new element should come. Okay. The maximum element right now it is 10. Size of this array is 5. So you have to start shifting. Okay. We'll be shifting the elements. So how to shift? From where you have to start shifting? How to shift? The last element, in this case it is 60. 60 has to be shifted to the next place. So 60, index is 4, has to be placed in the immediate its right side. That is in index 5. Okay. After shifting, how to shift it? Shifting is easy. Copying the previous positioned data to the next place. In terms of index, LA is the array. LA of J must be copied to the next place. This has to be repeated till you reach this particular index. From here, you have to start shifting. You have to copy that element to the next place till that position of interest. After shifting, the J value has to be decremented. You have to go to the previous place. You can see that in the animation. After the first shift operation, 60 is taken. 60 is placed in the next 60 is taken. 60 is placed in the next index. 60 is moved towards right side. It is moving. Old data is maintained there only, but a new copy is made in the next location. This particular color indicates that old copy. This is the new one. Our position is 2. Work is not yet done. Once again, go to the previous place. This is because of j equal to j minus 1. Earlier j was 4. J is set to n. J was 4. Now reduce j by 1. J is now 3. In that place element is 50. Copy that element to the next place. When you do like this, no, nothing will happen because already copy of the 60 is made in the next place. This is safe. You can alter this one. So 50 will come to this place. 50 is getting placed in this place. Another copy is also made, as you can see. 50, there are 2 copies. This is the fresh copy, this is the old copy. You can alter this one. Again, repeat that. J should be decremented by 1. 3 now becomes 2. Again, content in that place 40. Move towards right side. 40 is placed here. 40, 50, 60 are all copied data. This is a copy. 40 is old copy. We can alter it. So, increment the J value. J is this condition is now failed. J is not greater than K. You have to stop. So, but not the algorithm. This process of shifting should be stopped. Then we got the place of interest. This is a place of interest. In that place, what is that k value 2, in that place element must be copied. Element is 30. 30 must be copied here. You can see this is the element that is inserted. So in one line, when you want to insert element, all the existing element has to be shifted to higher index, because we want a place for the new element. The element has to be shifted to the higher index. In that way, you remember. For insertion, element has to be shifted to the end place, but the shifting should be started from the higher index to the position. If you do, if you perform the same shifting operation from here, no, you will get different result. Okay, care must be taken when you are performing shift operation. Shift must be started from the higher index to the position. Shifting by copying data to the next place. Okay, the last in this session, that is deletion. Before that, we'll see the program also. In this case, now don't forget to increase the value of size. As you know that after insertion, array expands. Earlier array size was 5. We added one new element, becomes 6. This is very much important. N equal to n plus 1. If we don't increase it, then we may not get all the elements. We will not get all elements. We will be stopping somewhere here. So array size has to be increased. It should be updated. The program is shown here. Okay, where to insert, position, what to insert, element, same array A only with maximum element 10. Okay, the current index are 0 1 2 3 4. There are 5 elements. N is 5. N is 5, size is 10. Is n is less than max? N value is 4, max value is 5. N value is 4, max value is 5. Oh, sorry, max value is 10. Array size is 5, n is 5, n is 5, max is 10. Is n less than max? Is 5 less than 10? Yes, this is true. You can proceed. Start shifting. Start shifting. Starting from n minus 1. N value 5. 5 minus 1 is 4. Almost same as that of algorithm. N value 5. N minus 1 is 4. You have to start shifting. Starting from this place. N minus 1. Till position. Position is this one. You have to start shifting by copying previous element to the next place. 60 should be copied to the next. 60 was in the previous place, must be copied to the new index, higher index. A of I must be copied to A of I plus 1. If you write A of I equal to A of I plus 1, is gone. Okay, so don't forget to update the value of n. This is how the array moves. Same animation. Don't forget to increase the value. After getting that, now copy the element, increase the value of n. This is C code. Earlier it was algorithm, now particular to C programming language. The last one, deletion. Removing one existing element from the array. You can perform deletion only element that array has got at least one element. You can perform deletion. When we don't have any element in the array, then we can't perform deletion. To perform deletion, array is required. Number of elements in the array, size of the array is required. Which element you are going to remove? This is to hold removed element. We need not provide input that item. The removed element will be placed in the item. Process is reverse of insertion. Now you have to move to the left side. We'll assume that the position 3, the size of the that maximum size is 10 and current size is 6. 10, 20, 30, 40, 50, 60 are the elements. I want to remove this 30. Position is 3. Index 0, 1, 2. Index 2. First step, initialize the counter. Which element to be removed? I want to remove this 30. LA of K. K value here is 2. K value is 2. not the exact position in terms of index to provide. Okay, LA of k. Then start shifting from that place j equal to k. So 40 should be copied to this place. Earlier we started from here. In case of insertion, we started from here. Now you have to start from very next element, immediate element. You have to copy that element to the previous place. 40 should be copied here, 50 to here, 60 to here. Each time after copying, advance that index by 1. How to copy? The next element must be copied to the previous place. Next element j plus 1 to be copied in the previous place. Okay, you can see that in the animation. 40 here, copy was there only, new copy is made in the previous place. Work is not at over. Take the next element. For that j equal to j plus 1. J was here, increase j by 1. J is now pointing to this element. This is now j value. Copy that to the previous place. Now 50 is copied to this place. Earlier 40 was there. It was erased, overwritten by 50. Again increase the value of j. J now pointing to this element. J equal to j plus 1 means pointing to this element. Element in that place 60. J plus 1 element is 60. Copy that to the previous place. 60 now placed here. That is, a copy was there here only, but new copy is made in the previous place. Okay, this is a status of the array. As you can see, there is a duplicate copy of the last element. We have to ignore that. To ignore that, you reduce the size. Size was 6, reduce it by 1. 1, 2, 3, 4, 5. Once you reduce the size now, you just ignore it. 10, 20, 40, 50, 60 are the updated array content. New size is 5. Okay. In case of insertion, array expands. In case of deletion, array shrinks. Okay. The same thing is shown with C program deletion. You can perform deletion if n is not equal to 0. If n is 0, that indicates that array is empty. We can't remove any element from the array which is having no element. Okay. Now we don't have that case. Elements are there in the array. N value is 6. Element to be removed is 30, whose position is 3, index 2. Okay. You have to read the position. Position value is 2 is right. Here 2 is right. Remember to input the index 0, 1, 2. Okay. You copy that data in the element equal to a of 2. 30 is the value. After this now, element value will be 30. The deleted element is 30. But work is not at over. You have to shift the element. You have to update the list. How to update? Bring this 40 to the previous place. Bring this 50 to the previous place. Bring this 60 to the previous place. Update the size. That code is given here. Next element is to be copied to the previous place. A of 1 must be copied to A of I, or how can you write that in C? A of I equal to A of I plus 1. You have to start from position from here. You have to repeat till you reach the last element, last position. Okay. Now the same thing you can see from the animation. 40 is copied to the previous place. Okay. This is the duplicate copy. 50 is copied to the previous place. This is the duplicate copy. 60 is copied to the previous place. This is duplicate copy. Okay, we have to update the array by updating n value. N value was 6. Reduce it by 1. Reduce it by 1. That code is n equal to n minus 1. N minus minus. N is decremented. N is decremented by 1. 6 is now 5. There are 5 elements in the array. Okay, the removed element is 30. Removed element is 30. Okay, so I'm giving you the outline. You just try this program. These are all the things given to you. We call this as signature. Okay, create, don't send any parameter, you assume in the global before starting any program, so that no need to send any parameter here. Okay, just start by looking to that code, no, modify according to this format. This is all the syntax for create, display, insert, delete, and the main program. Your code must be completed. This is a task given to you. Okay, with this I'll be ending my presentation. Thank you for listening.